Video, we're going to take a brief look at the modulo operator to do modulus operations in Python and how those can be used for some work in lists and sort of wrapping around in lists. Now, what is the modulus? Well, the modulus is basically if we take some number, say 245, and if we were to divide by, say, 10, right, then we would get 24.5, right? But if we take the modulus, which is the percent sign here, then we're going to get the remainder, which is 5/10, and so the remainder then is 5. All right, so print it out, we get 5. Now, whatever we do up to the front of this, we can make this longer. It's always going to take modulus, so it's of 10, so it's going to divide by 10 and then take the remainder, which in this case will still be 5. Another thing that you could do is, let's say we had 200 divided by 17. Alright, so we get this number, 11 point something. We could also do 200 divided by integer division, and so then when it divides, it's actually going to drop off everything in the decimal point. Alright, and then if we were to take the modulus, that would give us the remainder of 13, and if we took that part and divided it by 17, that would give us the decimal part. Right. So then if we were to add those together, 200-17 plus 200 modulus 17 divided by 17. So this is kind of like 11 plus 13/17. It's going to give us the same number that we had. We could also do 11 plus 13 divided by 17. All right. And that's going to give us the same value. So basically the modulus just divides by whatever number you have and then takes the remainder. You see this a lot with 10 because it's easy to take a 10 away because our number system is base 10. So if we did a modulus of 10, it would return 7. If we did a modulus of 100, it would return 67. If we did a modulus of 1,000, it would be 567. So we can use this way as a way to get at digits easily in the decimal system, but it can also be used to take the remainder when we use something that's not base 10, like 2 or 6 or any other number. So how is this useful? It's useful in a lot of ways, but specifically I'm going to talk about how it's useful for an array. So let's say we create an array, and let's just create some strings in this array. Alright, print stuff, print it out, you can see those there. Let's print out each one individually for I in the range length of stuff. Print stuff I. Alright, so it's going to print out each one of them. And what if in this case we wanted to print out not only stuff but also stuff the one before, stuff -1, and stuff I plus 1. So basically for each one we're going to get like ABC, BCD, CDE, DEF. Problem happens is when we go to the very first one, it's going to ask, it wants to do this, one before A, then B, and at the end it's going to do E, F, and then this one. So these are actually out of range, and if we print this out, it'll give us an out of range error, because when I is 0 in this case, it's going to ask for -1, 0, and 1. So it's a problem with this part right here. One way we could solve that is we could make the range smaller, so we could make it 1 to the length and skip over 0. But we're still going to get an out of range error for when when I is equal to 5, because we'll actually it'll ask for E, F, and then 1 past F, which it can't do because it doesn't exist. So another way, we could subtract 1 here. All right, so then we get the ABC, BCD, CDE, and DEF. Right? But what if we wanted to get the first one? What if we wanted to imagine that this actually looped? And so actually what we had was something more like something more continuous. Something more like this. So then if this were our starting point, we could actually go back and say F, A, B. And then if we were doing F here, we could actually do E, F, A. Well, to do that, we need to create an index. So let's say left index equals I minus 1. Okay, middle index equals I, and right index equals I plus 1. All right, and I'm going to change these right here so that this is left index, middle index, and right index. All right, and this should give us the same result that we have so far, right? But in this case, I'm going to bring it back to being between 0 and the full amount, which will give us an out of range error. But for this minus 1, what we're going to do is we're going to take the modulus of the length of stuff. So instead of just saying length of stuff, let's say 1, 2, 3, 4, 5, 6. Okay, so let's just put that 6 in there, and I'm just going to put a 6 in here too to just make it a little simpler. All right, and then here we're also going to take this and take the modulus of 6. Right? Now, this actually allows it to loop around so that you have FAB for A in the center, ABC for B in the center, so forth, and then when E is in the center, you get DEF, and when F is in the center, you get E, F, and A. It loops back to the beginning. One thing that I'll typically do when I'm doing something like this is, even on the subtraction part, I'll add whatever it is, whatever unit I'm doing the modulus by to there, because when the number is a negative number, in some softwares it's unclear about how the modulus is supposed to work, because you'll get a negative remainder. And some softwares will create a negative remainder and others will boost it back up to be a positive number. I find it helpful just to add that in there. And if you add this in and take the modulus, it's not going to do anything because it's just going to cancel out. There's going to be a remainder of 0 when you do that. You could also do it to this plus part when you're adding, but it doesn't really matter. It's only for this minus part that it really, that I would emphasize that part there. So here, now let's replace it with the length of stuff. Alright, to make it a little more dynamic. Oops. Instead of a 6. Alright, and we run it. And then we could then add more. Alright, and it'll take care of it just fine. Alright, so that's how you use modulus and the modulo operator to deal with looping through a list. You can also do this in 2 dimensions if you just have another dimension for j in range, and you have a 2-dimensional list. So you just have different modulus values that you run the modulus with for each of the different dimensions. So if one dimension is, in this case, 1, 2, 3, 4, 5, 6, 7, 8, and the other dimension is, say, 5, then you would use those different values for what you're using the modulo operator with. All right?